Okay, so here I'm going to walk through solving a practice final for my intermediate macroeconomics course. I'm going to not just try to give you the right answers, but explain how I think about them, why I'm asking certain questions, and what I'm trying to achieve when I'm writing an exam. So exam is marked out of 70 points. You have 3 hours. You should take a crack at every question, right? It never hurts to try, as long as you're not compromising your ability to do other questions, right? So, first of all, we have a data question. What are the normal ranges for unemployment and inflation? Well, I would say that if I bring up my pen, unemployment here would be something like what? Let's say 5 to 9%, something like that. And inflation would typically be 1 to, say, 3%. That's maybe the normal range for inflation. Obviously, right now, inflation is running a little bit hot. The key assumptions of the solo models. This is really important, right? You need to know about data, but this is a macroeconomic theory course. Constant returns to scale is the biggest one, right? The idea if you double your inputs, you double your outputs, but also diminishing returns to factors. There's probably an answer key for this exam somewhere, but I certainly haven't looked at it in at least a year. But those are the two ideas, right? If you plug in just more of one input, you get less and less and less diminishing marginal returns. But if you double your inputs, you get double the outputs. Briefly explain one benefit of possible benefit of positive inflation. For example, it helps debtors. That's one possible benefit, right? The real value of their debt falls. So they have to pay back less in real terms. Now, I would recommend strictly keeping to one possible benefit if you are writing this on an exam. But since this is an answer key, I'd like to tackle another one, which is maybe helps labor market reallocation, right? The idea is that, well, humans are not entirely rational, and so they feel differently about getting a 2% raise with 2% inflation than a 0% raise with 0% inflation. Or they feel differently about getting a 0% raise with 2% inflation than a minus 2% pay cut with 0% inflation, even if those things deal in real terms are identical, right? So it might give some flexibility to real wages, right? And wage flexibility is good because it helps people reallocate to where their labor is most valuable. Steep aggregate supply curve, right? So aggregate supply curve is a relationship between output and prices. And so when aggregate supply is steep, right, prices are flexible. You can see that prices vary quite a bit up and down a steep aggregate supply curve, right? Prices go up, prices go down quite a lot, as opposed to the counterexample here, where you've got a flat curve. That means that price can't really change. So steep is more flexible prices, flat is stickier. Another data question, normal ranges for nominal and real, right? We normally think about real. Real is maybe 1 to, or let's even say 0 to 3%. And then nominal might be something like 2 to 5%, roughly speaking, right? Because you're just hacking inflation on top. So, okay, now we are through some pop quiz questions. We're into the solo model on page 2. Great, making great time here. We should take some more time on these more technical questions because we know that they're a little bit more involved. They're really sort of testing you. We should look at the equations, right? We see that we have a production function with constant returns to scale. It's a solo model. There's no government. There's no foreign sector. We've got our law of motion for capital and population. And we are told that wages and capital are set in competitive markets. This is telling you that the wage is equal to the marginal product of labor and the return on capital is equal to the marginal product of capital. So now we are going to look at what is actually happening in the headline. So here's a story about 5% of the Canadian capital stock can no longer be used. So I'm going to model this as a reduction in K, right? In K. So how do we do that in the model? We need to, first of all, analyze the steady state. and let's draw a steady state diagram, right? So I notice that there is no technological growth here. A is a constant, so I'm doing growth. That informs my steady state, right? Here's my steady state, which is a story about K. Here's my savings curve, S of Fk. Here's my depreciation curve, N plus delta K. Here's my steady state, K star, right? So the key here is that there's no disruption to the steady state, right? No change in steady state because no parameters have changed, right? The fundamental economic forces in the model, the savings rate, the population growth rate, et cetera, are all, constant. None of them are changing. All that's happening is it's just a change in level of K. So if you think we started here at time 0, for example, you might think that, well, maybe at time 1, we started somewhere like here, where we are retiring a chunk of the capital stock due to the environmental agreement. So we are going to voluntarily just turn off some of our factories, reducing the capital stock available to us, right? So one way you might model this is by a reduction in the amount of K. And, right, a reduction in K is also a reduction in capital per worker because when we turn off a bunch of our factories, we don't kill a bunch of people at the same time. So population is constant the day that we turn off our factories, so capital per worker is falling as well. So if none of the forces, however, are affected, now you're going to have savings is greater than depreciation and capital is going to accumulate back to the steady state, right? So there's going to be return to the original steady state given time because none of the parameters have adjusted. So we get knocked out of the steady state, but we still are who we are. So we go back to the steady state given time. What does that look like for transition paths? Well, in terms of transition paths, now I'm talking about drawing something over time. And I want to check what transition paths I have to draw, right? So I need to draw transition paths for output, investment, and consumption. And that's easy enough to do. The key thing here is to think about what those are. Output is just a function of capital, right? Consumption is just a function of output. Investment is just a function of output. So as long as I understand what happens to capital, I get output. Once I know what happens to output, I get consumption and investment, right? And the story for capital is that capital is at, let's say it starts at the steady state, right? The shock hits, capital is immediately falling, but then capital is rebounding to the original steady state. Now, since y is just a function of capital, y is going to follow the exact same dynamics, right? It is returning to the steady state because it is following k along. The movement in k is, of course, rapid at first and gets smaller and smaller and smaller as we approach the steady state because the difference between savings and depreciation is getting closer and closer and closer to 0. If I want to think about consumption, well, consumption is just a constant fraction of y, so consumption also looks like this. And investment is just a fraction of y, so investment also looks like this, right? All of these things have the exact same behavior because they're all induced by y, right? And we know what's happening to y because we know what's happening to k, right? So again, in a perfect world, you might want to explain this just a little bit in words, right? No change in forces, right? So capital immediately drops and recovers. And fast at first due to the greater imbalance between savings and investment, right? So I'm recording this on an exam. If I was writing this, I would write a little bit more, but given that I'm recording and there's, I want to make this video as concise and as valuable as possible, I don't want to dwell over writing long paragraphs. Again, no need to write long paragraphs, but you should communicate to the person reading your exam that you know what's going on, right? That's what you're being evaluated on. Can you reasonably communicate that you know what's going on? Starting from the law of motion for capital in question 2, derive an algebraic condition for steady state capital per worker. Great. Okay, so the law of motion, we know exactly what that is. It's given in the equation. It says that kt plus 1 is equal to kt plus syt minus delta kt, right? That is the definition of the law of motion. I'm going to start off by divide by nt, because I know the steady state here is in terms of capital per worker, right? The question says that capital per worker, so I want to try to get this towards capital per worker. Kt plus 1 over nt is equal to kt over nt plus sf, I think actually I used a here, saf kt nt all over nt, subbing in the production function, minus delta kt over nt, right? I'm going to call k is equal to kt over nt, and I'm going to use constant returns to simplify the right-hand side. And then I have kt plus 1 over nt, I'm going to leave a little bit of space there, is equal to kt plus saf of kt. That's my constant returns. I get to sneak the n inside, minus delta kt. But now I have a units problem on the left-hand side, so I'm going to multiply by nt plus 1 over nt plus 1, and this gives me kt plus 1. So this gives me kt plus 1. 1 plus n is equal to kt plus saf of kt minus delta kt, right? Nt plus 1 over nt is just using the law of motion, right? I'm using this law of motion. Nt plus 1 over nt is just the growth rate, right? And so in the steady state, we have kt plus 1 is equal to kt is equal to k star. And this gives me that k star outside of 1 plus n is equal to k star outside of 1 minus delta plus sa plus saf of k star, or saf of k star is equal to k star outside of n plus delta. And that is the steady state condition we used in solving the model. Golden rule time. Well, the first thing is the golden rule is to maximize consumption. And consumption is equal to 1 minus sy, right? Or if you prefer, 1 minus sf of k. So there's two parts to this, right? There's two parts of maximizing consumption. It's your savings rate and the f of k. Intuitively, if you want to sketch this, right, if we think about k, well, I can draw y, I can draw 1 minus sy, and I can think about inducing, right, a level, n plus delta k. So when I pick a level of a savings rate induces a certain level of capital accumulation, right? Whatever savings rate I pick gives me my steady state, and this divides the economy up into investment and consumption, right? So investment is how much I spend, consumption is what is ever left over. And what I want to do is sort of rely on a little bit of calculus, is to maximize the gap between y and n plus delta k by setting the slopes equal, right? That's exactly what we're doing, right? We are setting the slopes equal. Wherever the slopes of these two things are tangent is where the gap is going to be maximized, right? That tells you that the slope of y, slope is equal to mpk, is MPK is equal to n plus delta, which is the slope of this line, right? Slope is equal to n plus delta. So that would be the golden rule level, but this is not actually important, right? Growth more important. Because hitting golden rule still doesn't yield growth, right? When you hit the golden rule, you've hit the exact best level of consumption possible, but that consumption is not growing over time. So if all you're doing is hitting the golden rule, you're sitting at the golden rule being stagnant, as opposed to growing as much as you can, right? If you are forward looking at all, you should care a lot much more about your growth, where you're going to be in the future, as opposed to getting the golden rule exactly right, because getting to the golden rule does not actually make you richer over the long run, right? Golden rule is nice, but being stagnant at the perfect level is much worse than continually growing and getting richer and richer and richer. Okay, now we're into the flexible price medium neoclassical model. We're first asked about labor supply. This variable right here, the obvious example here might be, for example, unemployment benefits. The existence of more generous unemployment benefits might make work less appealing, right? We saw this sort of over COVID with the CERB. You pay people to stay at home, they're less willing to work, right? That's the sort of shock that theta is capturing. We are now going to shock the model with a theta shock. We have to say whether it's going to go up or down, but we're going to reduce labor supply. So let's start this in the labor market, right? So we have a labor market, which is a story between N and W. We have labor supply and labor demand. We are shifting labor supply in, reducing the amount of labor that people want to supply, leading to a new equilibrium, right? Relative to the old equilibrium, the amount of labor is declining and the wage is rising. We now need to think about what else this is affecting. Well, you see we've resulted in a change in N. Well, I also now see N in the output function, right? I'm going to draw the rest of the economy. My goods market, output demanded, and output equilibrium. Or let me just draw that as a straight line. On a chalkboard, I probably would dash it, but here, let's just draw it as a straight line. This is my goods market equilibrium condition. This is my output demanded function, C plus I plus G, right? Here's my equilibrium between, right, goods market equilibrium. Induces an IS curve, right? Y and R. And we have a production function, Y equals to AF KN. And so what's happening is that our production function is getting shifted to the right, right? People are not working as much, so the amount of labor being supplied is going down, which means the amount of stuff being produced is going down. A society that produces less has to eat less, and it rations that shortage of goods by pushing up the real interest rate. So the new equilibrium is at a higher interest rate and a lower level of output, right? Now we need to translate that into YD. So with a higher interest rate, right, we know that consumption is falling and investment is falling. So we get a YD is equal to C plus I plus G of the new interest rate, right? If we think about this new interest rate of R1 versus the original interest rate of R0, the higher real interest rate is dissuading people from investing and consuming, right? Business plans make less sense with a higher interest rate, and individuals see the benefit of saving. Finally, we have the money market. That's the last piece of our neoclassical model. And that's a story between money and prices. We have a money supply curve that's set by the central bank. We have a money demand curve that's upward sloping because we've cheated and we've put price on the vertical axis, which is actually the inverse of the price of money. We have an original equilibrium here, and we need to remember that money demand is a function of the nominal rate and the size of the economy, right? Here, this nominal rate is going up, right? So we have this sort of higher opportunity cost. And this means that money demand is going to fall, right? People are going to want to hold less, and that means that prices are going to rise. So I've, again, tried to walk you through this. In a test, I would try to explain this more, and I've drawn these things a little bit too quickly, right? So the first thing is theta shifts ns, right? 2, lower n shifts the production function. And this leads to a higher R. I don't know why I'm writing so big. It's just maybe I've got the screen zoomed in a lot for this. 3, higher R reduces consumption and investment, right? In the goods market. 4, and higher R increases price level as money demand falls, right? So there's the complete story of this model, right? And, you really don't need to write a whole lot here. Now, these are the questions that I find the most unsatisfying, right? Because we're really not working with the equations. And that's one of the limitations of intermediate macro 1, that we don't really put the equations to work. I missed something here. This should be RT pi E YT. And you can see that, it's just a little bit frustrating. You either invest a lot in the mathematics or you go for this more diagrammatical approach, right? But you should try to think about the markets that you're being told, right? We were told about the money market, the labor market, the goods market, and output equilibrium. And we have markets capturing each of those things by and large. And again, you've seen this before. The graphs are kind of a little bit more similar to what you've seen. So I'll try to keep it a little bit more graphical, and 0 and 1, try to label everything. You don't really need to label every single point. It never hurts. It's more important that you label the lines, right? You want to think about making sure you've labeled every single curve and every single axis, because that's important, right? You're telling stories about these variables. When you leave things unlabeled, the stories you're telling are just sort of garbage. Briefly explain the following relationships, right? So here we've got this, and the idea here is that GT plus 1 up means that you are having less disposable income in the future. So you are poor, and that means you are going to consume less today and tomorrow, and that's what we called consumption smoothing, right? So this here is negative. The government is declaring an intention to take more of your income. You're going to be poorer today. You should, or alternatively, you could think of this as save more today preventatively, right? You don't know what the future, you know you're going to be poorer in the future, so you save more today to help out your future self. We are thinking about AT going up, so that means that workers are more productive. This means that the marginal product of labor is going up, right? The marginal product of labor, if you want to assume Cobb-Douglas, is AT K to the 1/3 over N to the 1/3. So if AT goes up, NP goes up, right? So ND increases, right? This would probably say NTD. ND increases, workers are more valuable, right? So if workers are more valuable, firms want more of them. This is a positive number, right? Here we're talking about inflation expectations. Inflation expectations go up. It means that nominal rates go up, right? Remember that the nominal rate is the real rate plus expected inflation. So if we expect inflation to go up, nominal rates are going to be higher. That means there's a higher cost to holding money. because you are foregoing it, right? The interest, right? If you hold money, by definition, you do not earn interest. So that means there is going to be less MTD, right? So this here is negative. Higher, if you expect inflation, you don't want to be sitting on money because money will be rotting in your pocket. Classical dichotomy. Dichotomy means, this is a bad question because it gives a real advantage to native English speakers. Dichotomy means split in half, right? To split something in half. The idea here is that you can solve the real side of model without caring about the monetary side, right? So the models is not linked fully to each other, right? You can talk about the effects of consumption or tax changes without talking about the model at all. You can solve the real side of the model separately from the monetary side of the model, right? So this is classical dichotomy. Money neutrality means that money has no effect on real variables, right? Money being neutral means that money only affects nominal variables and no real variables. And that's exactly what's true in this model, right? But yeah, this is just a bad question. It's kind of a definite, it's really just trying to get definitions, but it's dressed up like a much fancier question and sort of probably misleads students in terms of answering it. I would not expect to see this one on a real final exam. Exam writing is an art that you try to keep improving on the further and further and further you go. But that's what these two things mean, right? Classical dichotomy means that the real side and the money supplied side of the economies are split apart. They're not entangled like they would be in ISLM, right? In ISLM, you have the money and the real side entangled and they cannot be split apart. Here they can be split apart. Money neutrality means that money has no effect on real variables, only nominal, right? Ooh, nominal. Great. What else? So we're moving on to a fixed price short run model. We see our sticky price assumption. So we know that we're in a short run world and we are going to be increasing government spending, right? So here is one of my G's. We are missing Y is equal to C plus I plus G, which would also have G, right? So we're starting in the goods market here, right? Our goods market equilibrium has been disrupted. Y, YD, equilibrium, Y equals YD, C plus I plus G is equal to YD. So we have a goods market, we have a money market, right? Our money market is M, and now, however, right, we draw PTMD as sloping down because I'm putting the interest rate on the vertical axis, right? Because prices here are fixed. So if prices are fixed, there's no point in putting price on the axis anymore, right? This induces, as we've seen a million times, ISLM, and I'm just going to draw a regular LM curve here. And finally, aggregate demand, aggregate supply. Again, not a great question here because I'm not being specific enough about what I'm expecting you to do, right? It just says characterize and explain the short run and medium run effects. So in the short run, you're increasing G a lot. Consumption falls a little bit, but the increase in G is bigger than the decrease in C because the marginal propensity to consume is less than 1, right? So we get C plus I plus G prime. And that means we get a shift in the IS curve, right? The IS curve is moving out. We're going super fast here, giving us a short run equilibrium here, right? So this is my new one at, let's say, R1. I'm cheating a little bit, but so be it. R1, Y1, R0, Y0, right? So there would be my short run equilibrium, and we have a corresponding shift out in aggregate demand to match. Remember, your entire economy has to be consistent. If one output is increasing in one place, it better be increasing in another place. This is IT and YT, so money demand is increasing, right? And that is also consistent because we know the interest rate is going up, so we better draw the interest rate going up in the money market again, right? So there's a new interest rate and a new level of output, right? Again, you could maybe disaggregate this into more steps, because really you could think of, if you wanted to show it in ludicrous detail, you could first imagine that, well, the consumption investment government spending function shifts up, but then of course, right, the original shift is by this much, and we only get part of the shift because the interest rate is rising, but I'm just condensing those things into one diagram for simplicity. So that would be the short run, and I'll just sort of describe that, right? So in the short run, we get demand for goods increases via G, right? So this shifts IS right. Again, you have more Y for any R, right? The idea being, right, when the government comes in and spends money, it doesn't matter what the interest rate. For any interest rate, you have more demand for goods and services. This generates a higher R in equilibrium. Right? It increases aggregate demand and also increases money demand. Right? And that's what we've shown, right? We start in the goods market, we Y0, Y1, we've increased IS curve, we've increased money demand, we've shifted the aggregate demand curve. Now in the medium run, as we transition, right, we can think of wages have risen, but not prices. So businesses have sort of been screwed by this. Excuse my language. The idea is that businesses are running the same old business model as before the shock, right? Where they are still charging the same prices, they're still charging the exact same contracts to their customers, but they're having to pay overtime, they're having to pay higher wages to fulfill all this demand, right? This is unsustainable, so prices start rising, right? When the economy is running hot, as it is, prices start rising, and prices are going to start rising and keep rising until we get back to a long-term sustainable equilibrium back at potential output, right? So aggregate supply increases, P increases. So this means that money demand or price is going to increase further, right? The prices rising are like monetary contraction. So we have a new PTND consistent with even higher level of interest rate. And that means the LM curve is shifting back up, right? The LM curve is shifting up. Higher prices means that the supply of money has fallen in real terms, decreasing the LM curve and shifting this thing back down, right? So this will be C prime plus I plus G prime all at R2, right? The interest rate continues to rise until the demand for goods and services is squished back down to a sustainable level, right? So this means that R increases and CI fall until at potential output, right? Very briefly. Great. So there would be my complete short run to medium run story. And now we are thinking about a sticky price model. And the basic idea of why sticky price is working is that if interest rates have a lower bound, the normal mechanism of healing, or maybe I should say recovery, healing is a little bit too human, which is prices fall going to interest rates fall, doesn't work, right? And you get no natural recovery, right? In our short run model, when the economy is running cold, prices start falling. Prices start falling, act like a real increase in the money supply, reducing the real rate of interest, stimulating consumption and investment. But if interest rates have a lower bound, at some point, falling prices will not stimulate the economy because falling prices will be unable to lower the interest rate. And if you can't lower the interest rate, you can't stimulate consumption and investment. The ZLB region is maybe just a big decrease in I, but in general, you could have others, right? C, G, etc. But it needs to be an IS shock, right? Ideally. You can have LM shocks, but the classic ones are IS shocks. And if we draw that, we have, let's see. Let me just start with ISLM. So now we have our LM curve, our IS curve. We have this really big IS shock, throws us into the zero lower bound. So if we are plotting this in aggregate demand world, we would have our sticky price. We would have an aggregate demand curve that looks something like this, right? Because beyond some price level, further falling prices cannot stimulate the economy. So the aggregate demand curve goes vertical. We have a big IS shock, right? There's my big IS shock. And so now the economy is running colder than potential, right? So prices start falling, and prices start falling, but the prices start falling only lead to equilibria that are still well below potential, right? And the idea is that as the prices fall, the LM curve is shifting out because the real supply of money is increasing, but the LM curve shifting out does not get us away from this intersection because we are not actually stimulating consumption and investment, right? Prices are falling, but prices falling are not having any sort of force on real economic variables, and so we just get stuck. If you want to be totally precise about this and look at the money market, right? We have a certain amount of money supplied. We have a zero lower bound, right? Zero lower bound. We originally have a money demand function. And when the big shock happens, money demand gets crushed because money demand is a function of output. So money demand falls, right? And money demand is falling. Oop, meant to do that in a different color. Money demand is falling to something like here, right? This would be my new money demand function. And now, as prices fall, money demand keeps falling over and over and over, and we stay right here, right? We're not able to induce consumption and investment. So let's say that G falls a lot. This means that IS goes left. We have a recession at the zero lower bound. The economy is cold, which means that prices start falling. This means that money demand not money demand, but PTMD is falling. But when PTMD falls, you get no change in R. With no change in R, you get no stimulus or recovery. And the economy just sort of collapses as aggregate supply desperately goes down, keeps falling, hoping to spur economic recovery, but economic recovery never happens. And that's sort of your classic Keynesian liquidity trap. The government needs to bail out civilized society before we go back to the Stone Age story. And that's the entirety of the practice exam, right? We've got a solo model question. We've got some anecdotes about data, some fill in the blanks, applications of short run and medium run models, and I hope that was useful.